Let's consider finding the angle between two vectors using some new formulas. We derived this formula in class. I'm just going to show it to you now. If I have two vectors, we'll call them vector v. Here's vector v in blue. And in red, here is vector u. Well, notice what I've done. I've tied them tail to tail at the origin. So they're in standard position. This angle between them is called theta. To find that angle, I can use my second formula for the dot product. U dot v is also equal to the magnitude of u times the magnitude of v times cosine of the angle between them. So that's going to allow us to isolate cosine theta and eventually take the inverse of cosine to find that angle. So cosine of theta is going to be equal to the dot product, which we know we can find easily, over the magnitude of u times the magnitude of v. So if we want to find that angle, we'll say this is inverse cosine of the dot product over the product of the magnitude of the two vectors. And I let my calculator do all the walking to find the angle between the two vectors. Let's take this example. Find the angle between these two vectors. Now, vector v is given over 4 up 3, and vector u is given over 3 up 5. To find the angle between the vectors, I'd say, well, I know that u dot v is equal to the magnitude of u times the magnitude of v times cosine of the angle between them. So cosine of the angle is going to be u dot v over the magnitude of u times the magnitude of v. So cosine of the angle will be, well, I just got to find the dot product. Fairly simple. 4 times 3 plus 3 times 5 over the magnitude of u. I'm going to use the old-fashioned way, which would be 3 squared plus 5 squared square root, and the magnitude of v, which would be 4 squared plus 3 squared square root. Now, if I want to find the angle between them, I'm going to solve for theta. So theta will be inverse cosine of this monster here. And if I can, I just let my calculator do the walking. So the angle here is 22.2 degrees when I throw this all into my calculator, which makes me happy because when I look at my diagram, I'm expecting an acute angle.